You hear it all the time, right? The inevitable rise of AI. This future where machines are going to surpass human intelligence. But what if that entire story is just a myth? In this explainer, we're going to pull back the curtain on all the hype and explore the fundamental, and maybe even permanent, gap between artificial intelligence and the human mind.
I mean, this line from the movie Ex Machina, it just perfectly captures the story we tell ourselves about AI. It's dramatic, it's a little scary, and it frames this whole thing as some kind of evolutionary battle we're destined to lose. And look, it's a powerful narrative, for sure, but it's all built on one giant assumption, that AI is on this unstoppable path to becoming just like us, only, way better.
So, where does this idea of an inevitable AI even come from? Well, it's not just sci-fi movies. It's actually rooted in a really compelling theory about how technology itself grows. This right here is a look at futurist Ray Kurzweil's law of accelerated returns. And his whole theory is that the pace of innovation isn't just steady, it's constantly speeding up, exponentially. Just look at the timeline. It took over 1,000 years to get from paper to the printing press, but less than 30 years to jump from the first computers to the internet. Now, if you follow that curve, Kurzweil made a pretty bold prediction. We'll have human-level AI by 2029. And if that same logic holds, then by 2045, we'd hit what's called the singularity. That's the crossover point, the moment where machine intelligence doesn't just match us, but actually surpasses all human intelligence combined. It's the point where progress, as we know it, just kind of disappears into the great unknown. It's a fascinating, almost frightening idea. But what if that exponential curve isn't really pointing where we think it is? This is the core of our whole explainer. That vision of the singularity, it's a myth. And the very first crack in that myth is something called the narrowness trap.
And this just illustrates the problem perfectly. We see an AI master Go, one of the most complex games in the entire world, and we naturally assume it's intelligent in a general way. But here's the kicker. That same world champion system is a complete novice at chess. It literally can't make a single valid move. Current AI is hyper-specialized. Its incredible power in one area just doesn't translate anywhere else.
So here's the paradox, right? To make an AI amazing at one thing, you have to build a bias into the system. You tune it perfectly for the rules of Go. But that very tuning, the thing that makes it so successful, is also its prison. It's precisely what stops it from understanding anything else. So in the world of AI, success is narrowness. They're two sides of the exact same coin. And this narrowness isn't just some small limitation, It points to a much, much deeper issue. The real reason AI gets stuck in these little specialized boxes is a challenge that has stumped researchers for over 60 years, the problem of common sense. Okay, take a look at this sentence. It was first posed by a researcher way, way back in the 1960s, and it seems so simple. Little John was looking for his toy box. Finally, he found it. The box was in the pen. Now ask yourself, what kind of pen are we talking about here? You knew instantly it was a playpen, didn't you? You didn't even have to consciously think about it. But a machine? It's totally stumped. It has zero real-world knowledge about the sizes of boxes or toys or writing instruments. And that's the core of it. We all navigate the world with this massive, unspoken, maybe infinite web of common sense. We just know that toy boxes don't fit inside ballpoint pens. The idea of trying to program all of that background knowledge into a computer? Well, Bar Hill himself called it utterly chimerical, basically a complete fantasy. Okay, so if that's what machines are missing, what is it that we have? Well, it all comes down to this kind of mysterious and incredibly powerful form of reasoning that is uniquely human. You could even call it our superpower, the ability to make an inspired guess. All right, so there are basically 3 ways we reason. First up, you've got deduction. That's your airtight Sherlock Holmes-style logic, like the famous Socrates' mortal example. Then there's induction. Now, this is what almost all modern AI is built on. It's all about finding patterns in massive amounts of data. You show an AI a million pictures of cats, and it induces the general pattern of what a cat looks like. But then there's the third mode, abduction. And this is where things get really fascinating. This fantastic analogy from Bertrand Russell just perfectly nails the fatal flaw of induction. So a turkey is fed every single day for 1,000 days. It induces with more and more confidence that it will always be fed. I mean, it's got 1,000 data points, all confirming the same conclusion. But here's the problem. Induction is purely backward-looking. It can analyze the past, but it has no way to predict a radical, totally unexpected change in the pattern. And then
the day before Thanksgiving comes. In this story, machine learning is the turkey.
Abduction, on the other hand, well, that's our cognitive superpower. It's not about crunching data. It's an inspired guess. It's not ability to see a few weird clues and just leap to the single best explanation that makes sense of it all. It's how we read between the lines.
Let's see it in action. In Edgar Allan Poe's classic mystery, the police are completely stumped. You've got a locked room, a bizarre non-human voice that nobody can place, and no motive. The valuables weren't even touched. None of the facts fit together using normal deduction or induction. And then the detective makes this incredible abductive leap. What if the killer was an orangutan? Now, it sounds like a wild guess, right? But suddenly, all the bizarre clues just snap into place. The superhuman strength needed to commit the crime? Check. The strange non-human voice? Check. The total lack of a robbery motive? Check. The ability to climb up the building and escape through a tiny window? It all fits perfectly. That is abduction.
So if AI isn't really on a path to superintelligence, then what is it? And why are we so obsessed with this myth anyway? This brings us to a final, more philosophical idea. The writer Milan Kundera used the word kitsch to describe what happens when we simplify deep, complex problems into a simple story with an easy emotional payoff. And this idea, the dream that a beautiful, super-intelligent machine will just arrive and solve all of humanity's problems, that's a form of technological kitsch. It's a comforting fantasy that actually stops us from asking the harder questions about ourselves. You see, the philosopher Hannah Arendt argued that our very definition of what it means to be human has shifted. We used to see ourselves as Homo sapiens, or wise man, where the whole goal was understanding and wisdom. But now, she argued, we mostly see ourselves as Homo faber, man the builder, where our value comes from what we can make and the technical skills we have.
And if you think of humanity primarily as builders, then what's the ultimate project? What's the ultimate triumph? It's to build a copy of yourself. The quest for AI isn't just some technical challenge. It's really the pinnacle of that Homo faber worldview. It's a reflection of how we've come to define our own worth. Which leaves us with this final thought. In our grand quest to create artificial intelligence, are we truly on the verge of creating a new consciousness, a true reflection of our own minds? Or have we just gotten lost in the myth, and all we're really doing is perfecting a powerful, but ultimately very narrow tool, just a much, much better hammer?